Hello, everyone. I just wanted to give a quick lesson on rationalizing the denominator when you have the imaginary expression involved. All right. The first thing I need to define is something called complex conjugates. Simply put, those are just two complex numbers of the form a plus bi and a minus bi. All right. In other words, they are identical expressions except for the sign of the imaginary term changes. So if you have a positive bi in one of the expressions, the other one has to be negative. Right? So look at this example. It says state the complex conjugate, then multiply the two. So if I have 3 minus 5i, well, the complex conjugate will be 3 plus 5i. And that's the complex conjugate. Notice all I did was change the sign of the I expression. All right? Now let me do another one. Here's a bonus one real quick. Suppose I gave you something like this. Suppose I gave you 5i plus 4. What would be the complex conjugate? Yeah, notice you don't change the sign of the 4, you have to change the sign of the I. So it would be negative 5i plus 4, right? It's always the I that changes signs. By the way, I'm a bad boy because I should not have written this number like that. Remember that in standard form, I should have written this as 4 minus 5i. Okay? I'm sorry, 4 plus 5i. All right? All right. Now let's go ahead and find the product. The product of 3 minus 5i times its conjugate, 3 plus 5i, well, when you FOIL that out, you get 9 plus 15i minus 15i, and then minus 25i squared. Now notice that in this problem, the two middle terms, the 15i and the negative 15i, cancel. We know that I squared is negative 1, so that becomes just 9 plus 25, which would give me 34. So the product of these two numbers is 34. Well, if you notice, if you ever multiply a number, a complex number, times its conjugate, you always get just a real number as your answer. So that's nice. That if you ever have an I in a problem and you want to get rid of the I, you just multiply by the conjugate and that will clear it. So in this case, if I wanted to do an example B, if I multiply 5i plus 4 times negative 5i plus 4, when you multiply those out, you should get something that is a whole value, is a real number and no longer imaginary, right? Try multiplying that out, put pause, do it and see if you get this answer. Did you get 41? If you did it correctly, right? All right. Now let's take a look at how we can use the complex conjugate in rationalizing a denominator. Remember that the letter I represents the square root of negative 1. So if you see an I in the denominator of a fraction, really you have 3 times the square root of negative 1. So you actually have a square root on the bottom, which we know is not allowed. Well, using the idea of complex conjugate, the conjugate of 3i would be, well, there's two ways of doing this. I can multiply by negative 3i or just negative I, your preference. Let's go ahead and multiply by negative 3i just to stay consistent. If I multiply the bottom by negative 3i, I'd have to multiply the top by negative 3i, right? If I did, I'd get negative 6i minus 15i squared, right? Over negative 9i squared, right? Now from here I get negative 6i. Again, that's negative 1 plus 15 over, again, this I squared becomes negative 1, so over 9. Now I see two different fractions I can create, this fraction and this fraction. Well, 15 over 9 reduces to, dividing both by 3, 5/3. And negative 6i over 9 becomes negative 2/3 I, so minus 2/3 I. And that's my new answer in standard form. Notice that the I is no longer in the denominator. Coming over to example B, if I want to get that I out of the bottom, I would multiply by the conjugate, which would be 7 plus 3i on top and bottom. Now in the top I've got a FOIL, so I'm going to get 28 plus 12i minus 7i minus 3i squared. In the denominator, I'm going to get 49 plus 21i minus minus 21i minus 9i squared. Now, in the numerator, I can combine the like terms, change the I squared to a negative 1, and get 28 plus 3 is 31, and 12i minus 7i is 5i. So I get 31 plus 5i on the top. On the bottom, I squared becomes negative 1. 49 plus 9 is 58. And the 21i and the negative 21i cancel. Notice again, I got rid of the I on the bottom. I can break this up into two fractions, 31 over 58 plus 5/58ths I. And again, I got the I out of the bottom. And that's how you move the I out of the bottom of a fraction. Well, that's how you rationalize. We'll talk to you later.